So we remember from math class that Pythagorean theorem is c squared is equal to a squared plus b squared, where a and b are the two sides of a triangle. We'll call them a and b, where the hypotenuse is c, and we know that we have a right triangle. Now we want to be able to relate not only the sides of a triangle, but also be able to identify the angles. Now these functions that we're going to pull out here using sine, cosine, and tangent really relate the ratios of the sides to an angle. So if you think about triangles where you have, say, angle or side 2 and 4 and say side 5 and 10, the ratio of this is 4 over 2 and the ratio of that is 10 over 5. Both of these are equal to 2. So it would make sense that the angle in here would also be the same. And that's really what these functions do, is they relate the ratios of sides to a degree angle. So let's walk through and define some terms and then be able to see if we can find sides where we know, say, one angle and we want the other sides. So let's clear this out and let's define some of these terms. So if we say that this is angle in theta, this symbol theta is just any angle. And the S, or we'll define the sides first. So opposite, O is equal to opposite. H is equal to the hypotenuse. And A is equal to the adjacent side. So when we look at a triangle, opposite the 90, or the longest side, is equal to the hypotenuse. What is opposite the angle is directly opposite. You can also think of it as a little eyeball here, sort of looking opposite of where it is. Then the adjacent then is next to, but not the hypotenuse. So now let's define what the functions are. There's three functions: sine, cosine, and tangent. So the sine function, the sine of some angle theta, is equal to the opposite side over the hypotenuse side. The cosine of some angle is equal to the ratio of the adjacent over the hypotenuse. And tangent of some angle is equal to the opposite over the adjacent. Now these functions are valid for right triangles. So this is right triangles only. Okay, so let's walk through and see if we can apply these concepts. So let me take this off and let's see if we can apply these functions, apply the sine, cosine, tangent to a right triangle. So let's say that we have an angle of 30 degrees. So theta equals 30 degrees in here, and let's say that this hypotenuse is equal to 50. And that could be 50 meters per second, or meters, or any other unit. So we want to find, well, what is this side? We'll call that y, and what is this side down here? We'll call that x. But we need to put it in terms of opposite, hypotenuse, and adjacent. We have the hypotenuse identified. The y then is opposite my 30, so let's call that opposite, which makes then the x the adjacent side. So let's say I want to find the y first. What is y? Well, I know that my hypotenuse is 50, my theta angle is 30, and I want my opposite. So what you want to key in here is that the two sides that you have are opposite and hypotenuse, which points you to the sine function. So sine of my angle is equal to opposite over the hypotenuse. So using our algebra concepts, if we multiply both sides by the hypotenuse, we find that the opposite is equal to the hypotenuse times the sine of 30. So when you put that in, you just put that into your calculator, 50 times the sine of 30, and when you put that in your calculator, you should come up with this being 25. So opposite is equal to 25. Let's do the same thing now for the adjacent. So adjacent, and I'm going to use what I know is my opposite, so adjacent and opposite. So h again is 50. My adjacent is what I'm looking for, and my angle again is 30. So adjacent hypotenuse, this time puts me in the cosine function. So cosine of my angle is equal to adjacent over hypotenuse. So the adjacent becomes the hypotenuse times the cosine of the angle. The hypotenuse is 50 times the cosine of 30, and putting that in your calculator, you should come up with 43.3. If your calculator doesn't give you the 43, check your calculator to make sure that you are in the degree mode. You want to be in degree mode. So if you, right up next to your calculator, you should see a function for mode. Check on that. About the third one down, you'll see degrees and radians, and you want to be in degree mode for this process. So now that we know those, what you want to start to do is sort of become very comfortable with applying these so you can find any part of a triangle. Okay, but what if we have two sides and we want to find what the angle is? Well, let's use the same sides that we just did. We said that this side was 50, and we said that this side was 25, and we calculated this to be 43.3. So let's say we wanted to find out what the angles were, just using these sides, and we didn't have to have all three, but since we have them, we'll leave them there. So let's call this angle theta and this angle beta. Let's see if we can find those two angles. I'm going to start with this one, and I'm going to use my opposite side, the 25, and the hypotenuse. So opposite and hypotenuse is the sine function. So we started off again saying that the sine of my angle is equal to opposite over the hypotenuse. So putting what we know the sine of the angle is equal to opposite of 25 divided by 50. And when we do that, we get sine of our angle is equal to 0.5. But we want to know what the angle itself is, not the sine of the angle. So to find the angle, you use the inverse function. And you do that by just saying that the theta is equal to the sine minus 1 of 0.5. So on your calculator, you'll use the second function. So if we pull up a calculator, you can see that there's a second function. This one's just an up arrow. So if I put in my 0.5, let's see if you can see it, it's 0.5, and then I'm going to hit the second function, and you can see it becomes sine to the minus 1. You do the same thing on your calculator, so you have sine minus 1 of that, and that takes you right back to 30 degrees. So your angle then is 30 degrees. And that agreed with the problem that we just had. We could do the same thing for beta. And beta we can do, this 90 minus 30 gives us the 60, yes. But let's use the cosine function to see if we can find that one. So cosine of our angle is equal to adjacent over the hypotenuse, which is equal to 25 over 50, which is equal to 0.5. Notice here that, wait a minute, I have 0.5 and 0.5, but I'm using a different function, so I should get a different angle. So my angle then is equal to the cosine minus 1 of 0.5, and when I do that on the calculator, let's pull that up here. If I put 0.5 in, except this time I'm going to use the inverse function of cosine, I get 60 degrees, which is right what I wanted. Okay, so that confirmed what we had just done. So now let's see if you can try some of these and see if you can find all the sides and angles of a triangle knowing only two pieces of the puzzle. So if we go to those, these are some of the ones that I gave you in class to work through. So here they are again. So here's 60, and we had a side of 50, and we wanted to find this angle, and also this side. So that's problem number 1. Problem number 2, we said that this was side C. This side was 30. This side was 20. This was your right angle, and we called this theta and beta. And problem number 3, we had side C, angle B, 30 degrees down here, and we called this side 10, and this side was just letter A. And then this last one, we had side C, angle theta, 40 degrees, side Y, and this side down here was 100. So see if you can solve those, and we'll go through them next class.